Okay, this first slide is just a little bit of a refresher. So tell whether the abbreviation identifies a congruent statement. Number 1, SSS. Well, that's yes, side angle side. How about number 2, SAS? Well, yep, that is side angle side. How about 3? How about SSA? Well, no, that is not one of those ways to prove triangles are congruent. How about angle side angle? Yes. How about angle angle side? Yep, that's one. And how about angle angle angle? Nope, that is not one of the ways to prove triangles are congruent. Can you conclude that the two triangles are congruent? Well, it says explain. Well, don't I know the reflectives are congruent? And I don't have any additional markings besides these right angles. So if I take a look, is this enough information to give me that the triangles are congruent? No. I would need another side or another angle. Another set of sides or angles congruent. All right, looking here at number 8. Is this enough to say the triangles are congruent? So I have two sets of sides congruent. This side is congruent to this side. This side is congruent to this side. Of course, you can always assume vertical angles, just like in the last one we assumed reflexive. So are the triangles are congruent? Yes. The reason is because of side, angle, side. All right, today we're going to learn the last final way to prove triangles are congruent. Before we talk about triangles being congruent, we have to talk about some vocabulary. Looking at a right triangle. How do I know this is a right triangle? Well, look at right there, I have a right angle. There are some key parts to this right triangle. We're going to deal with more of this in second semester. So the longest side of the right triangle, the side that's across from the right angle, that is called your hypotenuse. Say that word to yourself, hypotenuse. All right, so the other two sides are just called legs. So this side would be called a leg, and this side would also be called a leg. So those are the key parts of a right triangle. So looking at our last theorem, hypotenuse leg, if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Okay, so this is only specific for right triangles. This is really your SSA situation, but it only happens, so let's draw a triangle. So if I have two congruent triangles, and they both have right angles, so they're right triangles. In this case, your angle is always 90 degrees for this SSA case. You're going to be given two congruent sides and one angle. Well, since this is a special case, we don't call it this. We call it hypotenuse leg. Because in order for the triangles to be congruent, the hypotenuses would have to be congruent. So take a look. This is my hypotenuse. And then either leg has to be congruent. So it could either be this leg or it can be this leg. It doesn't matter which one. So for this case, I'm just going to mark this angle. So I know that these triangles are congruent because of HL, hypotenuse leg. Remember, this only works in right triangles. Right triangles, right triangles, right triangles. So take a look at this proof. I wonder if you're saying to yourself, well, nothing really looks different. So whenever we're given anything with right angles, take a look. This says perpendicular. Won't I know that there's going to be right angle somewhere? So you're going to have to plan ahead on these proofs. So if I know that these are perpendicular, wouldn't I know that these angles are right angles? And then BA is congruent to AC. Those are those sides. And then I would have the reflexive. So how are these triangles congruent? Because of HL. So that makes it different in our proof. So if I'm looking, statement. So if AD is perpendicular to BC, given. Always after perpendicular, we state which angles are right angles. Looking at this picture, if AD is perpendicular to BC, then we know that angle, what letter's in the middle? Hopefully you're thinking D. Angle BDA and angle CDA. What do I know about them if they're perpendicular? They are right angles. And that's your definition of perpendicular. Well, typically we say we go from right angles to to congruent angles. In this one, I don't need them to be congruent. I need for HL for them to be a right triangle. So in this case, I can say, okay, triangle BDA and triangle CDA are right triangles. And the reason would be definition of right triangle. Think about that. If you have a right angle in a picture, in a triangle picture, isn't that mean that this angle is a right triangle? So that's the definition of right triangles. So now that I've said they were right triangles, let's write down our next given. So BA is congruent to AC, given. What have we not put in our proof yet? So we have right angles, we have right triangles, that's needed. We have set of sides. Look at BA. Where is BA? Isn't BA the longest side? And same with AC. So these are my hypotenuses. So I need a set of legs. So why would these triangles be congruent? Let's see. So my set of legs would be AD is congruent to AD because of reflexive. All right, so for 6, the triangles are congruent. Because of hypotenuse, and then here was my leg, so HL. All right, let's look at another one. You'll have to play the next video.